And now I'm going to show you 3 more lines as we get further up into Sumatra, or off the west coast of Sumatra. 1, 2, 3, 4, actually. Here, the slope is not as great as what we saw further to the south. Sediment is much thicker in the trench and being completely thrusted, building up this thrust belt of accretionary prism, and again, filling up small basins on top of the accretionary prism. Mostly in the Sunda area, especially eastern Sunda, the thrust faults are all seaward verging, which we call normal vergence. But there are places where we also see this sort of landward vergence. So the thrust faults are dipping seaward. Areas also where they're mixed vergence and kind of flower structures reminiscent of what we would see in a strike-slip fault zone. So again, this huge accretionary prism is at this point more than 90 kilometers wide. This is a diagram that I drew probably 40 years ago, where we had pretty poor seismic lines, but just enough to tell what was going on. We could see off Java the basement coming down, the oceanic plate with not much sediment on it, sediment in the trench getting off-scraped to form an accretionary prism with a basin behind. When we got up to Nias, the accretionary prism, now we see that it has come up above sea level, going all the way down. The trench has much more sediment in it, being accreted, forming this big convergent zone. Everything is being squished, and thrust faults are now being rotated up to vertical, filling up the forearc basin with sediment. By the time we get up to the north in the Andaman Islands, there are older sediments that have now come up above sea level. All of the sediment coming in from the Bengal fan, and here there's probably about 6 or 7 kilometers worth coming in, is being thrust in huge thrust packets, forming the Andaman Islands. So quite a difference from Java through Sumatra up to the Andamans. So now we're getting close to the northern part of the system. We'll talk a bit about the Andaman Islands in a minute, but now we need to talk more about the complications due to this oblique subduction. Here's the convergence vector. We see that pointing in this direction, by the time we get up to about the Andaman Islands, the convergence vector is almost parallel to the trench. Down here, it's not a whole lot more perpendicular. As I said, part of what happens is there is a big strike-slip fault that runs down the whole western part of Sumatra. It actually comes up here into the Andaman Sea, something that's not quite shown on this map. There is also a strike-slip fault that comes down here and cuts across through the accretionary prism. So again, all of this is having to do with the strongly oblique convergence. Another part of the system is in the Andaman Sea itself. This area here is actually a pull-apart basin with a small spreading center, oriented almost perpendicular to the margin, spreading north-northwest, south-southeast. They call this the Andaman Spreading Center. There's an awful lot of seismic data in here that people have worked on more recently, showing all the effects of this oblique convergence down to the south, hooking up to the Sumatra Fault Zone, going through the spreading center, and then up at the end of this diagram, hooking up with the Sagaing Fault, and then transiting all the way up through the main part of Myanmar. Let's take a quick look at, a seismic line down here that goes across this piece of the strike-slip fault coming down into the accretionary prism. So go back up. So much of this seismic line goes through the Forearc Basin, and then it gets deformed at its seaward edge by this fault. So here's all the sediment in the Forearc Basin with this West Andaman Fault, a series of very steeply dipping strike-slip faults that this ridge can be traced in the bathymetry, as you could see, up to the north, where it goes towards the spreading center and heads out to sea in the south. So we've got strike-slip faulting out in the forearc as well when we get up to the north. Similar onlapping sediment as we saw down to the south, with other deformation right in here. You can see these older sediments being squeezed into anticlines. So that line was down in here. The Andaman Islands themselves have been worked on for a number of years by our Indian colleagues. I'm going to show you this is a map of the Andaman Islands, geologic map of the Andaman Islands. So again, the Andamans are right in here. The spreading center we were talking about is in here, with spreading going up, hooking up to the Sagaing Fault, which goes up into western part of Myanmar, central part of Myanmar. And we can see the thing that's of interest for making the connection up to Myanmar. There are Cretaceous ophiolites down here in the southern island, Rutland Island, and also the capital of the islands here in Port Blair. Very nice exposure of the ophiolite, nice pillow basalts right along the beach that we were able to see during our field trip. These blue rocks here are what they call the Andaman Flysch, bits and pieces of ophiolite all the way up through the islands, and these Oligocene and younger sediments coming up through the Andaman Islands. In this map, they also show along this same zone ophiolites in Myanmar. Nagaland ophiolite in actually within India. Kalemio ophiolite up here in central Myanmar. Not sure why they didn't include yet another one down here at the tip of Ramri Island. Lin Tu Ong and I spent a few days there looking at those pieces of ophiolite with bedded chert over the top that were also dated by geologists at Chevron for us, though they're also in the range of Cretaceous for the ophiolites. So that ophiolite belt is continuous from Andaman Islands up through the western offshore region of Myanmar. There's another ophiolite belt back up here in the central part of Myanmar as well. So again, that Andaman Flysch is Oligocene or so. photograph of it here looks very much like the sandstones that Lin Tu and I looked at along the Tondoi coast. So all of these units are continuous, nicely continuous up into Myanmar, Cretaceous ophiolites with this bedded radiolarian chert. This regional map here allows us to kind of synthesize some of the observations in the northern part of the Indonesian part, anyway, of the subduction zone, where we're going from Java with nearly perpendicular subduction through the islands offshore, strike-slip fault down the middle of Sumatra, other faults up here cutting across this accretionary prism, the thick sediments of the Nicobar fan being accreted at Nias and the other islands along here, this bulge that comes out in this area, also affected by this West Andaman fault, strike-slip fault, and spreading up here in the Andaman Sea. When we get up into the very southern part of Myanmar offshore, we see almost parallel convergence along the slope, so it's mostly strike-slip. So here are just a couple last seismic lines. This is a line drawing area we were just talking about, the Andaman Sea in here, offshore Andamans where we were just looking, the strike-slip zone right here, and this lower seismic line over here we can see right up all the way at the base of the slope, just offshore, one of the pieces of 90 East Ridge is still a topographic feature that was onlapped in the early, probably Eocene or older. All of these younger sediments up on top. There's not even much of in this area because of the strike-slip. There's not much in the way of thrusting going on. As we turn the corner up here towards Ramri, Chetuba, Tondoi area, the next seismic line here does show sediment being thrust over the Indian sediments. Lots of very intricate thrusting and normal faulting, obviously due to the highly oblique convergence in this area. And for my last slide, sort of leave you with the thought that what I described today, the Sunda system down to the south of Myanmar and offshore, is quite, well, mostly fairly simple. Accreted sediment coming up, building up above sea level. Once we get into the Bay of Bengal, that continues on. Much sediment here being thrust out to the west in the Bangladesh area. These thrust faults here are very well observed, even on Landsat images. But then once we get very much further into the system, we start to see all kinds of different complications. The various strike-slip faults with also thrust motion on them. The big Sagaing fault here separating this older terrain called Sibumas. These older blocks here up in Myanmar, eastern and northern Myanmar, wrapping around into India. I'm not even going to try to explain any of the intricate details in there. People have been working now for 50 years trying to decipher all of this. It's so much more complicated than the nice frontal region out in here. So let me just try and summarize really briefly by asking a question. What did we learn today? Well, the main thing I think that we learned is the development of this Sunda accretionary prism overall is controlled by the amount of sediment on the subducting Indian plate. And that in turn is controlled by erosion of the Himalayas. So for the last 30, 40, 50 million years, India has been colliding with the Asian continent. The mountains are coming up, they're being eroded, dumping sediment out into the Bay of Bengal. That sediment, as it flows down to the south, runs into other topography. So the amount of sediment coming to the far south off Java, for instance, is not very much. The accretionary prism itself is relatively simple in the southeast because the subduction is nearly orthogonal. And because the amount of sediment is not as great down in that area. As we move up to the north towards Myanmar, off Sumatra, through the Andaman Islands, the prism structure gets much more complicated because of this oblique convergence and because of the amount of sediment. So when we shear all of that sediment coming into the subduction zone, it causes all kinds of grief for geologists who are trying to understand it. So the other thing that we've learned is one of the most complicated regions of geology on Earth lies within Myanmar. I think that all of you should have exciting careers trying to understand it. And I hope that you will be able to get back into the field very soon. And I thank you very much for listening. And if you have any questions, I'm happy to answer them.